My name is Jessica Chen. I'm a NOAA EPP MSI Cert Scholar from the City College of New York, and today I'll be talking about the impacts of smoke intrusion on pollution and health in the New York City area. So not sure if everyone's heard of wildfires or what's been going on, but there's been a lot recently, especially in the West Coast, and they've been increasing in duration, size, and intensity. Primarily due to climate change. And so this leads to an increased transport of the wildfire smokes, mostly over towards the East Coast. This can affect ground level air pollution as well as human health in the area. So wildfire smoke is primarily made up of particulate matter, but it's also made of gaseous pollutants, hazardous air pollutants that has hydrocarbons, which can also cause formation of ozone as well as water vapor. But our main concern is particulate matter, which is also known as PM, and ozone. And so now the goal of this study is to determine if there is a relationship between smoke intrusion into the surface air and the potential of air pollution and health outcomes. And so if some of you may or may not know, particulate matter and ozone are considered criteria air pollutants by the EPA, which means that at higher levels, they can pose as a public health risk. For the methodology, I'll be investigating the years of smoke events in the years 2018, 2019, and 2021. 2020 was omitted due to, obviously, COVID-19, which may affect the health data. And the months focus were primarily in June through August because those are the high points during wildfire season. We use CCNYs, which is City College of New York's salometer imagery, and LiDAR imagery, which is remote sensing tools, to determine the presence of smoke plumes in the area. And then to confirm these plumes, we utilize NOAA's Hazardous Mapping System, HMS, which uses real-time polar and geostationary satellite data coupled with fire product to digitize smoke plumes. So yeah, awesome stuff. And then, so we've also worked with the New York City's Department of Mental Hygiene, which provided us with asthma syndromic emergency room data. And then also used New York State's Department of Energy Conservation grounds level observation data, which is provided hourly. And so for now, we've decided to focus primarily in the Bronx area due to readily available data. So moving on. So the first case we'll be looking at would be of August 28th, 2018. This is the salometer imagery for that day. As you can see in the bottom area, this is in UTC time, by the way, and everything else will be in EDT time. And you can see that dark red area indicating of a smoke plume or possible smoke plume. Next is the LiDAR area. This time frame is late morning, early afternoon, and you can see possible smoke in the bottom left. And then on the right, we have NOAA's HMS, which the light green indicates light smoke in the New York City region. Okay, here's the first plot. It may be a lot to take in. So the red line, so this is ozone and particulate matter 2.5 compared to Bronx asthma syndromic emergency department visits. So as you can see, the red line is day data versus the other lines in the gray are hourly data. The dark gray with the circles are ozones. As you can see on Monday, there is a large peak above 70 parts per billion, which is considered an exceedance of ozone due to the National Ambient Air Quality Standards. And the second circle, which is a little lower on Tuesday, is high levels of PM2.5 around nearing 40 micrograms per cubic meter, which is also an exceedance in the National Ambient Air Quality Standards. And you can see with the red line showing the emergency department visits, there's a slow increase that seems to be in relation with the slow increase of particulate matter nearing Tuesday, which is the smoke event. So on this graph, we added a green line, which represents relative humidity. We just wanted to see if there are any relations to the other variables and the air pollution data. As you can see, there's lower, which is also, there's two y-axis, by the way. Asthma syndromic data is on the right, sorry, your left, and ozone particulate matter and humidity will be on your left. On your left. Okay, next slide. So on this slide, we've added temperature. So as you can see on Tuesday and Wednesday, there's high levels of temperature, which can also contribute to the formation of ozone, which can explain higher levels of ozone in the preceding days. So we would like to focus on these 3 days. You can see clear indication of high ozone and high particulate matter, coupled with increasingly high emergency department visits in the Bronx area. And as you notice on Wednesday, there is a slower decline, possibly due to the remaining high levels of ozone present. Okay, so here is case study number 2, which would be of July 26th of 2021. As you can see circled here on the bottom is also indication of possible smoke plumes mixing with the planetary boundary layer. Here on the LiDAR, also late morning, early afternoon, you can see the amount of aerosols and possible clouds in around 2 o'clock. And on the right, the NOAA HMS indicates heavy smoke, which is represented by the red lining. So here, same exact plotting, ozone and particulate matter on your left and asthma syndromic data of the Bronx on your right. So here you can see high levels of particulate matter on Monday, which is the smoke event, above 50, around nearing 55, and then extremely high levels of ozone nearing 100 on Tuesday. Little intro music. Yes, ozone deserves intro music. Anyways, here, moving on, as you can see, there's actually slightly lower relative humidity on those 2 days, Monday and Tuesday. And you can see the little step ladder of emergency room visits that also corresponds with the increasing particulate matter. And here we have temperature. Temperature is also moderately high, around 30 to 32 degrees Celsius in the Monday and Tuesday, which is about maybe 90 degrees Fahrenheit. And then as you can see here, Monday and Tuesday are the events we want to look at, which is very high emergency department visits, high particulate matter, and high ozone. So here we have a third case, which will be of July 20th and 21st of 2021. The deep red indicates a very heavy smoke plume throughout these 2 days. So moving on. So this case was quite interesting because there's a clear relation with high levels of particulate matter on Tuesday, very high levels of emergency room visits. However, ozone levels are fairly moderately low, around, I believe they're around 50 parts per million, which can be mainly due to the low temperatures that we see here as well, around 30 and 25 degrees Celsius. So ozone requires high temperature to form more, so that can be that can alter our results a little bit. Okay, so thus far, the exceedance in both ozone and particulate matter 2.5 seems to correspond with invasive smoke, which seems to attribute to the increase of asthma syndromic emergency department visits in the Bronx area. And further research will be required since some smoke plume days do not show a clear correlation pollution, as we saw earlier with the ozone. And temperature and humidity may contribute to air quality and health conditions, since temperature and humidity at extreme levels can affect human health. And for future work, we'll look into more correlation based on geolocations at the zip code level and by borough, and we would like to incorporate the lag effect into asthma syndromic emergency department analysis. And I would also like to incorporate more socioeconomic factors such as income and education if I'm looking at marginalized communities in New York City. That's all.
That was great. Next time you give a talk with music, we'll serve cocktails.
That would be very helpful.
We have some time for some questions.
Yeah. Great talk, first off.
Oh, thank you.
I have a couple questions, but I want to kind of sum it up.
Okay.
Wildfire smoke, as we all know, ejects at a pretty high height. So in order for it to get to New York and get back down to the surface impact, can you kind of expand upon how you do that? Okay, so what is the mechanism that brings the smoke from the upper troposphere deck down to the surface to impact New York? What do you think?
We have seen smoke plumes that are above the planetary boundary layer, so we're looking at the ones that seem to be mixing into the planetary boundary layer. So that's why there's only a few cases, even though there is a lot of significant amount of smoke events that can happen from here.
Okay, and then the second piece of that question would be, how can you determine if it's actually the smoke from the fire that causes the increases in ozone at the surface or the PM? Like, is there a way you can separate that from just other causes?
So I know in further research, we can also consider the particular matter size that can, so like there's PM10, PM2.5, PM1, which we can also look more into. As for ozone, higher levels of PM that were not there, we would just probably have to look more days prior to the event. As you can see, like a significant increase that may not have to do with usual day-to-day activities. So that large peak that was not contributed to like everyday New York levels. So that was an indicator of possible smoke intrusion. Yeah.
Quick question about the meteorology. It kind of goes to his question as well. I think one of the things you could potentially do is start to look at the high split model.
Yes, we were considering that.
Yeah, because that'll tell you kind of the back trajectories of where that air comes from. ARL is the developer, so Dr. Miles, in her laboratory, they're the developer of that. So if you needed a collaborator on that type of project, you would definitely have to go to ARL. So just what are your thoughts there, and what have you thought about with regards to kind of the meteorology and understanding the meteorology so that you can do?
So I've had used the high split model to look at the fire, the smoke events, but I didn't include it in these slides. But I just, because the high split model, they model, I guess, the potential transfer of the smoke. It's not extremely accurate, so it's all it's up in the air. So for now, we're focusing on New York City, and then maybe we can further our research to look at different states to see if they actually transition that way. Thank you.
We have time for one more question. But we'll go to the questions. Go ahead.
Yes, Will?
Changes of potential environmental justice issues. Have you thought about looking at child vulnerability when it comes to asthma? And
yes. So the asthma data that I have, it can be broken down into age groups and the zip code level of the boroughs. So yeah, we can definitely look at into like child level and older adults as well.
And final question, I see.
I was curious, so you're using zip codes. I know zip codes can be kind of finicky sometimes.
Yeah.
So what is making you use zip codes as opposed to like maybe census tracts in general?
Since so as of right now, I haven't been using zip code. I've been using borough data. So I would like to further look into zip code data. But that's a great question, but I'm also not sure if census has hospitalization data, and if it is, I'm not sure if it's privy to the public to use. There might be some process that we have to go through.
Great, thank you so much.